Okay, so this is number 4 from your exact value practice. So what we're going to take a look at here, a little bit different, but a little bit of thinking required, I suppose, with this question because it's a little different, right? So you'll notice there that the hypotenuse is 12. So that's just throwing a wrench. It's not crazy, but we'll need this little skill here in order to answer some of the questions in on the later questions on this sheet, right? So the way I think about this question is, it's been provided to me that the opposite side length is the thing that I'm looking for. And it's also been provided to me that I have the hypotenuse. So in relation to SOHCAHTOA, I haven't been told anything about the adjacent side length, nor do I really care about it. The question's not asking for it. So anything with an A in it, I'm just going to ignore. And subsequently, I see that I'm just going to use sine to represent this question. And so what I'm going to do is write that the sine of 45 degrees has to be equal to opposite over hypotenuse, which relative to this triangle is going to be x over 12. Now, you all know, because we've done a few videos on this and done a ton of it in class, that the sine of 45, if I were to draw out the triangle for 45 degrees, it would be 1 root 2. So I also know that the sine of 45 is going to be 1 over root 2, right? So I could basically replace this sine of 45 to be 1 over root 2. It has to be equal to what I'm seeing on that triangle of x by 12. Now this should hopefully look like something that you've seen before. Well, you do it with sine law a ton, right? So you're going to cross multiply and solve. So I'm going to get left with 12 has to be equal to root 2x. And then to get x by itself, I'm just going to divide both sides by root 2, right? So I get x is going to equal 12 by root 2. Now there's something that we never ever do, and it is leave a radical in the denominator. So I'm just going to rationalize by multiplying by root 2 by 2. And so x is going to be 12 root 2 divided by what would be the square root of 4, but is now square root of 4 is 2. And so subsequently I can simplify the 12 divided by 2 to be 6 root 2. Okay, which is what you will see the answer being on the answer page. We're going to apply the exact same logic to question B here, except if I again write out my SOHCAHTOA, I'm going to see that relative to the triangle, I haven't been provided anything about the opposite side length. So in this question, I'm going to ignore anything with an O in it, opposite, which leaves me with just cosine. And so I'm just going to do the exact same work here where this is the adjacent side length, that's hypotenuse, there's your angle of interest, and I'm going to use cosine. So the cosine of, here, I'll do it over here actually. We'll draw a line down here to separate the questions. So the cosine of 30 degrees is going to be, again, just like the last question, adjacent over hypotenuse, which relative to this triangle is going to be x over 8. And then you know from class, again, just like the 45-degree triangle, you know that if I drew the 30, 60, 90 triangle, where the 30 is relative to the initial arm, that must make that 1 and 2 and root 3. And so the cosine of 30 is actually going to simplify down to adjacent over hypotenuse, which is root 3 by 2, which has to equal x by 8 by the statement above. So now we can solve. So we're going to get 8 root 3 is going to equal 2x, and then I can divide both sides by 2 to get x. And so we're going to be left with x has to be 4 root 3. If I'm correct, that should match the answer that's on the answer page, which is right here. We're good, 4 root 3. Okay, so there's a couple quick questions. We're going to need that skill in some of the later questions, like 5, 6, 7, 8, maybe 6, 7, 8. I can't quite remember, but we'll need that skill where they've provided us some information that does not correspond with our special triangles, but we can figure out what the x is in relation to the angles that they have provided to us in the question. So kind of an important question there for later questions.